Now we'll do some fun stuff coding the system that will instantiate a lot of wood planks in our scenario. Okay, so I can get rid of this one. I was using it just for explaining how we would destroy a single wood plank. And I'm going to create a new script, and this script is going to control the wood blocks creation, right? So I'm going to call it wood block creator. There you go. Open it up and want to develop. And hopefully you remember the mathematical approach that we did in the last lecture, because it's going to be useful in this lesson, as of course we will apply this principle in the code. It's not something that is too sophisticated, so it shouldn't be hard to remember. In this class, we will need a reference for all the wooden planks that we've created as prefabs in the first lecture of this series. So I'm going to define a vector of game objects, so an array of game objects, and I'm going to call it my blocks. I'm also going to get rid of the update function. I'm not going to be using it. What I want to is a function that gives me a lot of information with regards of the system that I'll be building. So I'll have two functions here. I'm going to have a function that's called create blocks group. This won't take any parameters. And I'm also going to have a function that's called get block information, or get blocks information. And I want this function to return me a lot of parameters that has to do with our system. I want to have access to the screen width. I want to have access to that multiplier that I'll need. I want to have access to the number of columns. And we have two ways of doing this. We have two ways of having a function that returns several values. We can have a structure that holds all the different values that this function will fill and therefore return. Or we can pass them as reference parameters. A reference parameter is a variable that's passed in to the function, but as a reference. So anytime you modify this variable inside the function, it will modify the actual variable that was passed in as parameter. So this function will have a value reference to the block width, because this is something that we already have access to. This function will have a reference parameter, that's the screen width, because we don't need the screen width in pixels. We need the screen width in world coordinates, because our block width is in world coordinates. Okay. We'll also need the number of columns, and that's actually an integer. And we'll need that multiplier, that scale multiplier. And that's pretty much all we need. So as said, we'll need the screen width in world coordinates. And how do we do to get the screen width in world coordinates? First of all, we need a reference to the camera. I taught you earlier how to get that reference to the camera by exposing a variable of type camera here and manually assign it in inspector. But in this lecture, we're going to do something different. We can have access to the camera that's actually rendering our game by a static variable that's inside the camera component. So I'm going to have a reference here, a local reference. I'm calling it cam. And this is going to be camera.main. As you can see, the first enabled camera tagged main camera. And if you go back to Unity, there's just one camera here, this one main camera, and it has a tag main camera. So every time I get access to that main attribute, Unity will search for the first camera it encounters that has this tag main camera. In our case, there's just one, so we can be sure that this one will be returned. Alright, so now how do we fill the screen width? So the screen width will be cam.screen to world point, and we want to pass in the rightmost part of our screen. So a new vector 3. And for x, of course, we need to have screen.width. That's the width of our screen. For y, it doesn't really matter. So 0, 0 here. I'm going to show you what does this imply in a few seconds. So I need to subtract the leftmost part of our screen. So I need to subtract a point, cam.screen to roll point, new vector 3, and this one is 0, 0, 0. But this returns me a vector. If I subtract these 2 points, it gives me a vector. So I'm just gonna wrap this subtraction in between parentheses, and I'm just gonna type in dot x because I want to get the x component of this vector, and this is actually gonna tell me the screen width. What's actually going on here is that when I type screen.width 0, 0 and I try to convert that into world coordinates, is going to get this point of the screen and convert that into world coordinates. And when I get 0, 0, it's going to get this point and convert into world coordinates. So what I'm doing is I'm subtracting these 2 points. So I'm going to get a vector that goes this way, but this is of course in world coordinates. And as you can see, the y and the z components of these vectors are 0, and I'm grabbing just the x component, which is going to give me therefore the screen width in world coordinates. And as said, the columns is basically the screen width divided by the block width, but we want the integer of that number. So columns is going to be screen width divided by block width, and we could just do a typecast of this entire thing to an integer. It's gonna wrap the division into parentheses, and I'm going to typecast that to an integer. And typecasting to an integer is the same as doing a floor operation, because it's going to get rid of that floating point bit. And for the scale multiplier, what is our equation? We basically want the block width times this scale multiplier times the number of columns to be equal to the screen width. So our scale multiplier will be screen width divided by block width times the number of columns. Alright, so scale multiplier, I'm just gonna copy from that. Screen width divided by block width times the number of columns. There we go. So all the information we need is going to be filled up by this function. So in this create blocks group function, I'll have to have those local variables that will hold the value for screen width, columns, and scale multiplier. So I'm going to define 2 floating point values, screen width and scale multiplier. I don't need to give them a value because they're going to be filled up by this get blocks information function. And I also have to have a variable for the columns. And what I do now is I can call the get blocks information function. And what do I pass in for the block width? I know that all these blocks inside this array, they have the same width. And I'm talking about world coordinates width. So let me give you an example here. I'm talking about the distance from this point, which is the leftmost point, to this point, which is the rightmost point, in world coordinates. How do I have access to that? You can see that each sprite has a sprite renderer, and inside this component we have this information. So to access that, I'm going to assign this to a local variable, float block width, and I can pick any of the indices of these blocks, given that it's an index that exists. So I'm going to get 0, because I'll assume that there's at least one block that's filling this array. Dot get component, and I'm going to get the sprite renderer component, because as said, the information of the size of this block is inside this component, and I can access bounds from here. So this is actually a cube, or maybe a box that will wrap this sprite. It's something that's not visible, but it exists. And we want to access the size, so the total size of the box. The box is, of course, a non-visible box that encapsulates our sprite in the world. And we want to have access to the X component because this is our width. And here I can pass in the width, the block width. I can pass in the screen width as being an out parameter, so out screen width, out columns, and out scale multiplier. So now we're getting all the information we need to build that structure. Actually, I'm forgetting something here. I also need the screen height, and you'll see why within a second. So I'm just going to define the screen height, and I'll have to have the screen height as being passed in as an out parameter here as well. So out float screen height, and I have, of course, to fill it up. So now you already know how to do this. This is screen height, and I'm gonna encapsulate all of these into parentheses, so I'm gonna already insert one. So cam.screen to row point, and I'm gonna get the upmost bit of our screen into world coordinates. So this is going to be 0 for X, or anything you want for X, it doesn't really matter. Screen.height, which is the upmost part, and 0 for Z, minus cam.screen to world point, new vector 3, and 0, 0, 0 again. But this time, instead of X, we're going to grab the Y component. And we need to do this because we'll have to place the elements here. So the center of our game is, of course, here. But if we subtract half of the width and we sum half of the height, we end up being here, so we are ready to put the element. But there's one problem as well. Our element has center here, so we need kind of to sum half of the width of the block and subtract half of the height of the block to get it positioned here. Instead, it will be here. So wouldn't it be easier if we just put the pivot of this 2D element as being its top left corner? And yeah, this is a good approach. We can just go to Unity, select all of these 3 elements. Actually, they're sprites. So select all of their 3 sprites and change the pivot here as being top left. Just hit apply. And now all the position is given by its top left corner. But you see that the collider has been dislocated. So we can just reset its collider to get it centered correctly. And we can select all of the sprites here in our prefabs folder. And in the little gear here, we can reset the information for the box collider. So now we can see that collider is perfectly centered for all of the 3 variations. And since this is a rather long programming session, I'm going to be ending this video here just after I get rid of this error here. It said no overload for method get blocks information takes 4 arguments, and that's because we added one more argument to our function, but we didn't add this parameter into the place where we actually call in this function. So as you can see, just after screen width, we placed another parameter, which is the screen height. So we need to define this screen height here as being a float. And we need to pass in out screen height. Oops, I've already defined it here. Sorry. There we go. Now it looks good. We won't have any errors, but this won't have any functionality. We of course need to instantiate these blocks, and we're going to do this in the next lecture.